Hello and welcome to another video. I've been recently teaching my friend Juicebox Hero how to write Python. And as part of that, we're going over a lot of the basics, and I figured I should record something about some Python basics. That way, if I ever make a course, I'll have some material I can start with. Anyway, the first video is about strings, and even if you already know a lot of Python, there's going to be some stuff in here that might surprise you. So let's jump into it. Okay, we're going to start out extremely simple. A string in Python is a series of characters, and they are usually represented by quotes. So if you can have either single quotes, you can have double quotes, you can put single quotes inside of double quotes, and you can put double quotes inside of single quotes, and they are completely the same. So even if you have a single quoted string, it is the same as a double quoted string. Python is flexible in this, and it lets you use either of those. This is actually a source of contention in Python because there is a camp that really likes double quotes, and there's a camp that really likes single quotes. Pick one that you like and stick with it. I like single quotes because I don't have to press the shift key, but that isn't really a big reason, and it doesn't really matter. Set up a formatter, and then don't grumble about it. Okay. The other thing, the other way you can define strings in Python is using triple quotes. Either triple single quotes or triple double quotes. Either of those, again, are the same, and a triple quoted string is the same as a single quoted string. In fact, the quote type also still doesn't matter there. The reason for triple quoted strings, which I'm going to refer to as both these and these as triple quoted strings, even though this is a triple single quote and this is a triple double quote, saying that over and over is kind of a pain. The point of triple quoted strings is they preserve new lines and white space inside of them. So if you were to start a triple quoted string and put hello and then world and then end your triple quoted string, you'll see that we get a string that starts with a new line. There's a new line character there. Then there's this indentation here at the beginning, another new line, more indentation, a new line, etc., etc. So triple quoted strings are a way to preserve new lines in them. Now, one little trick with triple quoted strings is I often find that I'm trying to represent file contents, and I find it ugly to write, something like this. To not have a blank line at the beginning of the file. There is a escape sequence, and we'll get to escape sequences later, that allows you to ignore the first line of your triple quoted string. And that is if you put a backslash at the beginning of your triple quoted string. And in honesty, besides escape sequences, I think this is the only acceptable use for backslash in Python. So you can see here, we've eliminated that extra new line there. But that's a little bit off topic. Okay, so triple quoted strings preserve white space in them. One thing that you might sometimes want to do is get rid of the leading indentation of your string. So let's say you had defined a variable and you had written hello, hello, and then you went to print it, and you're like, oh, I didn't want this to be indented. I only indented it so the code looked nice. There is a function in text wrap called ddent, and if we do text wrap.ddentx, and some languages have this built in, but Python does not. So textwrap ddent will remove any leading indentation and make everything line up. That's a little imprecise. So if you have things that are further indented than the minimal indent, it will preserve that as well. So if you'll see something like this, and then print textwrap.ddentx, you'll see that this indentation relative to these is still preserved. So that's kind of how ddent works. Okay, so we've gone over single quoted strings, double quoted strings, and both variants of triple quoted strings. The next thing that I want to talk about in string syntax is escape sequences. So escape sequences, we've already seen one of them here, allow characters to be reinterpreted as a different value. The most common escape sequences that you're going to see are tab, which is \t, and the other one that you'll see a lot is new line, and actually we already glossed over that because we saw new line above, but I didn't say anything about it. So \n is our new line. An escape sequence is the \ character followed by some stuff after it. There are some that are single character escapes, such as tab and new line, and then there are some more complicated ones that we'll get to. The other escape that you'll see pretty often is if you have single quotes and you want to put a single quote in it, you can escape the single quote and allow you to preserve the contents here. The other thing you can do is if you don't want escape sequences, because I think they're ugly, you can switch your quote type to avoid that. That of course doesn't work if you have both quote types in here. You'll get a syntax error, and you can either escape that, or you can make it into a triple quoted string, because you can have normal quotes inside a triple quoted string. There's a whole bunch of ways to avoid that escape sequence. But that's the other one that's common, is escaping quotes. The other escape sequences that are a little bit more rare are the carriage return. So if you've ever written Windows code, you'll know that Windows has this \r\n. This is how Windows has new lines, and it renders as a new line here, but this carriage return is actually a very weird character. What it does when it's printed is it moves the insertion back to the beginning of the line. So if you were to write hello just \r and then HA, what this is going to do is it's going to print hello, then it's going to go all the way back to the H, and then it's going to write this over top of it. So we'll get hello instead of hello. It's a little bit of a weird character. Another one that I don't have enabled right now is \A. This is the bell character, and if your terminal is hooked up for this, some terminals will flash, others will make a ding. I mute the ding and I turn off the flash because I find it annoying. It is also the same character that happens if you're tab completing something. For instance, if you tab a bunch of times, well, actually, why is it not working? Okay, so there's actually a bell character that's happening here, but again, I have it off because I find it annoying. Next is backspace, and you almost never want to use this because it's very, very confusing. The backspace character doesn't do anything on its own, but it moves where the insertion point's going to be. So it's going to, go back one character to this O, and then you can, I don't know, put an A there instead. So this allows you to move the insertion. And again, this is something that you almost never use. Now I've got a few that are, I think, obsolete. I've never seen them in use in reality. The first is form feed, which apparently renders as a new line and a tab. Maybe it lines it up. Oh, it lines it up. Oh, that's kind of cool. Yeah, that isn't so bad. And then there's vertical tab, which renders the same way. I'm not really sure why it renders that way, but anyway, that's form feed and vertical tab. I don't think you'll ever see those. Next is octal escapes. Octal escapes, again, start with a \, and then start with the number 0. Well, actually, I think they can start with any octal character. Does this work? We're gonna try it. I usually write it like this. I think it needs to start with a 0. No, it doesn't need to start with a 0. Oh, interesting. Well, I think it's probably better if you start it with a 0, because then people who understand octal escapes will quickly recognize this as an octal escape. What this is actually doing here is this is a special ANSI escape sequence that's interpreted by my terminal and turns into this background blue color, and this is the reset sequence. So this 033 is an octal escape. I believe it's also XF. No. I don't remember that actually. We can actually figure out what it is. We do 033 here. X1B. Which brings us to our next escape sequence type, which is hex escapes, which are done with \x and then a 2-character hex. For instance, one of the ones that I have written in my notes here is B6, which is not the one that I thought it was. One of these is supposed to be the micro character. Dang it! Oh, there it is. B5. Okay, I was off by 1. So this is another hex escape. It's just a way for these sequence of characters to be interpreted as a different character. The other one that I have memorized is our Unicode escape. So there's both a 4-digit and an 8-digit Unicode escape. For the 4-digit Unicode escape, it's a little u. So this is our snowman here. And the 8-digit escape is capital U. And actually, I think you can do this. You can do 4-digit escapes with the capital U. You just 0-pad them with 4 zeros. But the one that I know is 1F643, which is upside down smiley face. These are like the 2 Unicode escapes that I have memorized. Snowman and upside down smiley face. You don't need anything else. But those are specified with a capital U and then the 8 hex digit code point. What else is there? Oh yes, these are ones that I didn't know about until relatively recently. There is a named escape, which is \N, and then you can give the Unicode character's name in here. So for instance, this will give us snowman, and this will give us upside dash down face. And of course, you could do levitating man in business suit or whatever other character name that you happen to have memorized. I think you can do like Greek capital alpha. Is it just capital A? Oh, I don't know. Anyway, if you know the escape sequence name, this can often be, a self-documenting way. But I usually just use the actual characters in line in my source. And Python has supported this very well since Python 3, where UTF-8 is the default character encoding. So you can just put, your emojis or other Unicode characters directly in line. Okay, so that's escape sequences. Oh, the last one, which I glossed over earlier, which is an escaped new line, which does work with single quoted strings. That feels wrong. I would only use it with triple quoted strings, but apparently it works with single quoted strings. Weird. Huh, Python is strange sometimes. But that's our last escape sequence, which is to ignore a new line character inside of a triple quoted string to control the white space a little bit better here. Okay, so that's escape sequences. Basically, / plus some other characters treats a series of characters as a different character. Now I want to talk about raw strings. Raw strings in Python are the first string prefix we'll show you, which is you just put an R before the string. And if your string doesn't contain any escape sequences, this will just be the same string as normal. Now, what raw strings do is they ignore escape sequences. So if you have a say \F in here, which would have been that form feed character, you would get oops, that was weird. We get a form feed character here if we have this \F. But if we turn this into a raw string, the / will be treated literally. Oh, I forgot one very important escape sequence, which is if you need to escape the \, you can use 2 backslashes. I should have included that one. But you can see here, this \F string is equivalent to the raw string with \F. So it's treating this / literally. Now, one unfortunate side effect of this is if you're trying to control white space using that trick I showed you earlier, it's not going to work. You're going to get a literal \ in addition to your new line there. So you gotta be a little bit careful with this little trick, especially if you're combining it with raw strings here. The other thing when we're talking about escape sequences is Python currently Python ignores invalid escape sequences. So for instance, if you do \, which is not a valid escape sequence, Python is just going to say, oh, I knew what you meant, and treat this / literally. However, this may become a syntax error in the future. And in fact, it's a warning right now, and you can upgrade it to an error by doing this. So if you see this, you'll see we get syntax error, invalid escape sequence. So maybe at some point in the future, this will become an error. Right now, it's just a warning. So I usually find it best to make sure you're using correct escape sequences. There's linters that will cover this as well for you. And you can always convert these. Well, you can't always convert these to a raw string, because if you had other characters in here as well, converting this to a raw string would no longer make this a tab and instead make it a literal \T. So the other way to fix this is to double that \ there and escape it. Okay, so that's raw strings. It's just the R prefix on any string literal, and it causes \ to be treated literally. Now, one quirk is you can't actually have a raw string that is just a single \ here. So this is how you make a string that contains just a single \, and it looks like 2 \ here because that's the representation. It's basically regurgitating what we put in. So this is one little edge case. I kind of know why it's like that, but it feels a little bit weird to me. Okay, the last thing that I want to talk about, I'm only going to scratch the surface on this because there's a whole meta language for formatting. But the last thing we're going to talk about is F strings. And what an F string is, again, by default, it doesn't really do anything, but it allows you to put placeholders and expressions into strings. So for instance, if you had thing equals world, and we wanted to print hello, hello, thing, Python uses curly braces to have internal expressions in an F string. This will format this variable into here. And you can also put whatever expressions in here as you want to. So if you did, 5 plus 5, it's going to evaluate this as a Python expression. And sometimes, depending on the characters you use in here, you'll have to parenthesize these. A few examples are, oh, this is way more advanced for this video than you need. But if you had an assignment expression, which you should never do, this is terrible code. Yeah, it'll give you a sort of weird error message, but if you parenthesize it, it'll work. So sometimes you need to parenthesize this in here. But basically, F strings allows you to templatize a string and inject them with variables or other expressions. There is a whole formatting meta language for the values that go in here besides the expression. I'm going to show you the most common things that I run into here. There are, this could be an entire video on its own, just going over the meta language, but I'm going to show you a few things that I find useful. The first is the debugging feature of F strings. This is new in Python 3.8. If you put a trailing equals on your expression here, the Python will convert this into a debug string that shows you the expression that you ran here and then the representation of the value here. So for instance, if we did 5 plus 5 equals here, you'll see that it writes out our nice little expression here that 5 plus 5 is 10. I usually use this for debugging or, quick little repr messages that make it easy to understand what's going on. I talked about representation strings. Basically, the repr built in Python will give you a string that is the representation, basically the programmer's, what you would type to get that variable. That's kind of how I think about repr. Python has a shortcut for doing repr inside of a placeholder, which is to do bang R on the end of it. This is take this value and show me the repr of it. Bang R here is the same as calling, explicitly calling repr here. They do the same thing. This one is probably a little bit faster because it's in the actual runtime. Doesn't matter from a performance perspective, but that's bang R. The other thing that I'll show you quickly is floating point formatting. So if we had just put X in here, you'll see that we get the full right out of this number here, but maybe we only want 2 decimal places of it. So this is one way to convert decimal places there. And there's, a ton of ways to do format specifiers here. This is only scratching the surface. But the other thing about F strings is if you need a literal curly brace in here, you have to double the curly braces. So if we don't double the curly braces, you'll see we get a empty expression not allowed. But if we double the curlies, you'll see they'll show up in the output. You can also put as many placeholders as you want in here, so you can join as many string parts as you need. But that's scratching the surface on F strings. And these are new in Python 3.6, and this equals thing up here is new in 3.8. So if you're on a specific Python version, get on a newer one. But anyway, that's all of the string syntaxes that are important. Technically, there's byte strings, but they're not actually strings, and maybe I'll talk about those in another video. But that's the other thing here. Oh, the other thing is you can combine raw and F strings. I like to call them French strings. Which allows you to, have literal backslashes in here. Let's say we had dot and then X linked to F. You can either do FR or RF. I like FR because it's French and it's funny. But anyway, okay, so that's string syntax. Hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.